Okay, this lesson is all about synthetic division, but before we start into synthetic division, we're going to talk about a review of polynomial division. So, for instance, if we're asked to divide the polynomial 5x cubed minus 6x squared minus 28x minus 2 by the quantity x plus 2. If we're using polynomial division, we use a process that's similar to long division. And let's say, for instance, you have, like 12 divided by 5. So in long division, you'd put the 5 outside, the 12 on the inside, and you know what to do here. So how many times does 5 go into 12? It goes 2 times. Multiply the 5 and the 2 to get 10. And then at this next stage, you subtract, and now you have a remainder of 2. So you say that 12 fifths is equivalent to 2 plus 2 fifths. So that's your process of division there. It's very similar in polynomial division, but here's what you do. So you start off asking yourself, what can you multiply x by to get 5x cubed? Well, it's kind of predetermined. The only one thing that will work. So that's 5x squared. And the reason you choose that is because now you're going to multiply 5x squared by this polynomial. And in multiplying 5x squared by that polynomial, you get 5x cubed plus 10x squared. And similarly, as you did in long division, at this step, you subtract. And so what happens is this first term becomes negative, and this next term becomes negative. So in effect, you're doing 6x squared minus 10x squared, which is negative 16x squared. Then you bring your next term down, so minus 28x. And then the process simply just repeats itself. So what do I need to multiply x by to get negative 16x squared? Well, negative 16x. So then, multiplying, that gives me negative 16x squared. Negative 16 times 2 is minus 32x. Now I subtract at this step. And so when I subtract this polynomial, it changes both signs on the inside. So 28x plus 32x is 4x. Then I bring down my next term, so minus 2. And I repeat, so what do I need to multiply x by to get 4x? So that's going to be plus 4. So when I multiply 4 times the x plus 2 polynomial, I get 4x plus 8. And when I subtract at this step, 4x minus 4x cancels, that goes to 0. Then I have negative 2 minus 8, which is negative 10. And at this point, I don't have any other terms to bring down, so this is the last step in the process. So I write my final answer here. I can express it as 5x cubed minus 6x squared minus 28x minus 2 divided by x plus 2. So the quotient here is going to be what's sitting on top of this fraction, or the division bar. So that's 5x squared minus 16x plus 4. Then it's going to be minus 10, which is my remainder, over the original denominator of x plus 2. In the exact same way how I've written, this fraction here. It's always your remainder over the original denominator. Now, that is how we, perform polynomial division. The interesting thing about polynomial division is, under certain conditions, you can actually make this process a whole lot easier. If you notice some things that are kind of similar here, like for instance, we have a 5 here and a 5 there. That's similar. We had negative 16 here, negative 16 there. 4 here, 4 there. So there's a lot of things that are similar. And actually all these x squareds, x's, x cubes, all they're doing is just kind of lining up like terms for me. So there's a different process here that's called synthetic division. And with synthetic division, write that down, you're only really working with the coefficients of the parts that you're dividing. And it makes the process a whole lot easier. So there's lots of different ways of notating synthetic division, but here is the way that I do it. So first I take the part that's in the denominator, and instead of using a positive 2, I use a negative 2. And the reason I use a negative 2 here is because, you know, at every single step of polynomial division, I had to remember to subtract, and then I had to distribute that negative. Well, if I divide using a negative 2 instead, that's just taken care of. I don't have to worry about that, remembering that. Now I'm going to take the coefficients of my original polynomial. So 5, negative 6, negative 28, and negative 2. And I'm just going to write those in a line. Now, in performing this, I'm going to do this right here. Okay, and it'll make sense why in just a second. Now the first step you do is whatever your first number is, you just bring it straight down. All right, because if you'll notice in the original division, whatever this number was is what that number ended up being. Okay, and this only works if this leading term coefficient is a 1. So that's kind of important. All right, we'll explain that sort of thing in just a minute, but I just bring that term down. But now this number gets multiplied by the negative 2. So if I do 5 times negative 2, that gives me negative 10. And that's what I place right here. All right, and the negative 6 and negative 10 now get added. So that gives me negative 16. So notice the negative 16 was my second value in the quotient. All right, so now I do negative 16 times negative 2. So that's going to be positive 32. And when I add negative 28 and 32, that gives me 4. And I just keep repeating this. So 4 times negative 2 is negative 8. And when I add negative 2 and negative 8, I get negative 10. So this value over here is my remainder. And that's kind of why it's separated by this bar right here. And then the coefficients off this polynomial, this is a constant, this is times x, and this is times x squared. If there were more terms, it would be times x cubed, and so forth. So I get the same result here using the synthetic division. My result becomes 5x squared minus 16x plus 4, and then minus 10 over the original denominator of x plus 2. So the exact same answer that I had just a second ago, but arguably much simpler. Now, different teachers notate synthetic division in different ways. This is just the way I do it. The process is always going to be the same no matter how you notate it. One thing that's really important though, the process of synthetic division only works when your denominator has to be of the form x minus r. So it has to be linear. The leading term coefficient has to be 1. And it's of the form x minus r because when I place this number into my synthetic division, I'm going to be taking the opposite of that value. So that's the requirement here. As long as that's the case, you're allowed to use synthetic division, and it's much easier than polynomial division. So let's walk through a few examples just using synthetic division. So I want to divide this here. So my divisor is x plus 2, so I'm going to put off to the side a negative 2. The coefficients of my polynomial, it's x cubed, that's just understood to be 1, plus 7x squared, so plus 7, plus 13x, I'm going to put a 13, finally a 6, and then I'm going to do this right here and start synthetic division. So bring the 1 down, multiply the 1 by negative 2, so that's negative 2. 7 minus 2 is 5. 5 times negative 2 is negative 10. 13 minus 10 is 3. 3 times negative 2 is negative 6. And when we add these together, the result is 0. So I have a remainder of 0. So what this means is, this is my constant, this is times x, and this is times x squared. So this polynomial divided by x plus 2 gives me x squared plus 5x plus 3. All right, another example, a little bit larger polynomial. So the denominator is x minus 1, so that means I'm going to use a positive 1 over here in the corner. And then I have x to the 6th power, its coefficient is 1. Now, it always assumes that you have descending powers of x. If you'll notice, I don't have an x to the 5th power. It's missing. So I need to put in a coefficient of 0 just to represent something x to the 5th power, or else my final answer will be off by 1 degree. So then 3x to the 4th, that's going to be a minus 3. 2x to the 3rd is a positive 2. Negative 6x squared is minus 6, minus 5, and 3. Now there's more terms in this particular problem. The process isn't any more difficult. It's just going to take a slightly bit longer. Bring the 1 down. 1 times 1 is 1. 0 plus 1 is 1. Then 1 times 1 is also 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Negative 2, or 2 minus 2 is 0. 0 times 1 is 0. Negative 6 plus 0 is negative 6. Negative 6 times 1 is negative 6. This is negative 11. Bring that up, and negative 8 is my remainder. Now, so this is my remainder. This is my constant. This is times x squared, times x cubed, times x to the 4th, and times x to the 5th. So my final answer here, after division, is x to the 5th plus x to the 4th minus 2x cubed the 0x squared, I can leave x squared off, and it's going to be minus 6x minus 11 minus 8 over the original denominator of x minus 1. All right, now that you should be familiar with the process, let's look at a conceptual example of a little bit more what's going on here. So consider the quotient 2x cubed plus 3x squared minus 16x plus 10 divided by x plus 4. Now if I do synthetic division, let's see what I get. So 2, 3, negative 16, 10. So bring the 2 down. 2 times 4 is negative 8. This is going to be negative 5. That's 20. That's 4. Negative 16 and negative 6. So what that means is this results in 2x squared minus 5x plus 4 minus 6 over the quantity x plus 4. Okay, now if we multiply both sides of the equation because the equation I'm referring to is that this right here, this polynomial, is completely equal to the polynomial that I've written in blue. If we multiply both sides of the equation by x plus 4, well, let's see what happens. So if I take 2x cubed plus 3x squared minus 16x plus 10 all over the x plus 4, I don't need that parentheses there, and I'm saying that's equal to this right here. So I'm multiplying both sides by the quantity x plus 4. Okay, looks like it's going to be complex, but actually not much is really happening here. So on the left-hand side, the only thing that happens is the x plus 4's cancel out. So I have 2x cubed plus 3x squared minus 16x plus 10. On the right-hand side, the first polynomial, 2x squared minus 5x plus 4, that just gets multiplied by x plus 4. But the negative 6 over x plus 4, the x plus 4's cancel, and I'm just left with minus 6. So essentially, this process is kind of hiding a little bit of a detail that's really important to this chapter, is that I've basically taken this polynomial right here and I've factored it into this right here. Now, it's not exactly factored because of that remainder of minus 6. It technically is, but it's not exactly what we're really thinking of when we talk about factoring. But it's the same sort of process like when you take, x squared minus x minus 6, and you factor it into x, in this case, minus 3x plus 2. It's the same sort of process, but I've factored a cubic polynomial rather than just a squared polynomial. And that's an important thing to understand because that's kind of the basis of what we do throughout most of this chapter. Now, more to that will come. For now, one thing I want you to notice is let me define a function, 2x cubed plus 3x squared minus 16x plus 10. So it's defined exactly based off of what this polynomial is right here. Okay, so I've just made it a function. And the reason I made it a function is because I can evaluate functions at different points. So I'm going to evaluate f of negative 4. So that would be 2 times negative 4 cubed plus 3 times negative 4 squared minus 16 times negative 4 plus 10. All right, so this isn't going to be a whole lot of fun, but I'll work through it here. So 4 cubed is going to be negative 64 times 2 gives me negative 128. 4 squared is 16. 16 times 3 gives me 48. Negative 16 times negative 4 gives me 64, then plus 10. So let's see, this would be negative 128 and 48 should be negative 80. 64 and 10 is 74. When I add those together, I get negative 6, which is interesting, because go back a little bit. Look at what the remainder is. The remainder was negative 6. And here, the evaluation of the function at negative 4 is negative 6. So it's kind of leading us into an alternate way of evaluating a polynomial So instead of just plugging in a number, we actually end up with the ability to do synthetic division and just find the remainder. We'll get to that. But let's look at a little bit more intuition as to why this might work the way it does. So for instance, if I express my function in factored form, okay, because remember, the 2x cubed plus 3x squared minus 16 plus 10 factored into that thing right there. So I'm going to express this in factored form. And now I'm going to evaluate f of negative 4 and see if things are a little bit more obvious. Well, if I plug in negative 4, it looks like I've got a little bit of work ahead of me, but it's actually not so bad because negative 4 plus 4 results in 0. Anything times 0, so this entire polynomial is multiplied by 0, so 0 times all that stuff, which I'm not even going to bother computing, is just going to be 0. So the result is always going to be negative 6, and that negative 6 is always going to be coming from my remainder directly. So that leads us to what's called the remainder theorem. The remainder theorem says that the remainder of a polynomial function divided by x minus k is equal to f of k. So again, the importance is that we have a choice in how we evaluate polynomial functions. We can choose to either evaluate f of k directly, just plug the number in, get the result, totally fine. Or perform synthetic division on f of x at x equals k and find the remainder. In most situations, especially if you don't have a calculator handy, you'll find option B actually to be easier. So let's try it out. So if f of x is x to the fourth, or negative x to the fourth plus 3x squared minus 4x minus 5, let's find f of negative 3. So I'm just going to perform synthetic division using the value negative 3 on the coefficients of this polynomial, which would be negative 1, and then since there's no cubed term, I need to put in a 0 for that. Then 3, negative 4, and negative 5. Okay, so evaluating, bring the negative 1 down. Negative 1 times negative 3 is 3. That's 3. Negative 9, negative 6, 18. Negative 4 plus 18 gives me 14. And then negative 3 times 14 is negative 42. And so I get a result of negative 47. So f of negative 3 here is negative 47. All right, another example. Evaluate f of 2 if f of x equals x cubed plus x squared minus 5x minus 6. So I'm going to put 2 up to the side here, and then my coefficients, and do the synthetic division. It's 1, it's 2, 3, 6. That adds up to 1. That's 2. And I get a negative 4 as my remainder. So f of 2 is negative 4. Okay, next example. Evaluate f of 2. F of x is this polynomial. So put 2 off to the side. So 1 times x to the fourth minus 8x cubed plus 10x squared. Don't need the plus there. Plus 2x plus 4. Okay, bring the 1 down. That's 1 there. 1 times 2 is 2. Add these, negative 6. So negative 6 times 2 is negative 12. Those add to negative 2. Negative 2 times 2 is negative 4. And this adds to negative 2. Negative 2 times 2 is negative 4. And that adds to 0. So f of 2 is equal to 0. Okay, so now that I think you've got the hang of that, let's work with another definition. So this definition says that x equals k is a 0 of f of x if f of k is equal to 0. So if you evaluate a polynomial at a number that results in 0, this is called a 0 of the function. Okay? So is k equals 1 of 0 of f of x equals x cubed minus 4x squared plus 9x minus 6? Well, we just do the synthetic division to find that out. So bring the 1 down. 1 times 1 is 1. That adds to negative 3. Negative 3 times 1 is negative 3. 9 minus 3 is 6. 1 times 6 is 6. We get 0. So what that means is f of 1 is 0. So this function at 1 evaluates to 0, which means x equals 1 is a 0 of the function. All right, so basically it's a point where it crosses the x-axis. Okay, is k equals negative 5 a 0 of this polynomial? So let's find out. So put the negative 5 off to the side, and 1 times x to the 5th, 0 times x to the 4th, minus 25x cubed, minus 7x squared, 37x, and negative 18. Now, bring the 1 down. 1 times negative 5 is negative 5. These add to negative 5 and multiply to 25. Sorry about that. Oops, made an eraser. Which add up to 0. 0 times anything is 0. Negative 7 and 0 is negative 7. This makes 35, which add up to negative 2. Negative 5 times negative 2 is is positive 10, and that results in negative 8. So f of negative 5 in this case is equal to negative 8. So k equals negative 5 is not a 0. So only if the remainder equals 0 is that the case. All right, and one last example here, and I believe you'll be ready for the homework. So is k equals 2 a 0 of this polynomial? 1, negative 8, 10, 2, and 4. So bring the 1 down. 2 times 1 is 2. Negative 6, negative 12. 2 times negative 2 is negative 4. This would be negative 2. 2 times negative 2 is negative 4, which results in 0. So f evaluated at 2 equals 0. Therefore, oops, I keep writing x there. K equals 2 is a 0. So we'll discuss more the implications of it being a 0 later on, but for now, being able to test is the important thing.